All right, team. Today's lecture is going to be a problem session for section 7.5. So I wanted to go over some more examples to give you just some more resources, as well as I'll teach you how to use the calculator to make some things simpler, okay? So all these problems are pulled from the back of section 7.5, the exercises that come with the book, okay? So the first problem we're working on is number 2. And here we're given a probability distribution and asked to compute the variance. So when you're given a probability distribution and asked to compute the variance, you have a couple of options. As I went over in the lecture, a couple of different formulas you can use. But what I want to do this problem is find, I want to use the following formula. Variance of x equals the expectation of x squared minus the expectation of x squared. So this is one formula we can use. So in order to use this formula, we just need to add another column to the distribution, which will be the outcome squared. Trying to fit all this into one shot. Okay, so that's the formula we're using, outcome squared. So you just go through and square these values. -1 squared is +1. -1/2 squared is +1/4. 0 squared is 0. 1/2 squared is 1/4. And 1 squared is 1. Okay, so you need to have these squared values for your outcomes as well. All the probabilities stay the same. So first we find the expectation of x, which is the mean. So there we're just taking the outcomes and multiplying by the probabilities, adding it all up. So -1 times 1/8 plus -1/2 times 3/8 plus 0 times 1/8 plus 1/2 times 1/8 plus 1 times 1/4. All right. Oops. So we take all of that and punch it into our calculator. So -1 times 1/8 plus -1/2 times 3/8 plus 0 times 1/8 is a 0. So I'm not going to do that one, plus 1/2 times 1/8. And then plus 1 times 1/4. So we get an expected value of 0. That's a totally valid result. Okay. So now we find the expected value of x squared. So here we're going to use all the square values, but the same probabilities. So 1 times 1/8 plus 1/4 times 3/8 plus 0 times, anytime I get a 0, I'll just leave it out because it's not going to add anything to the sum. 1/4 times 1/8 and then 1 times 1/4. Okay. Separate that out, give us some more room. So we punch that into the calculator. 1 times 1/8 plus 1/4 times 3/8 plus 1/4 times 1/8 plus 1 times 1/4. And that gives us an expectation for x squared of 0.5. Okay, don't spaz out, phone. Getting a little spazzy here, people. Don't know why. Okay, so now that we have our expected value of x and our expected value of x squared, to find the variance, we use the above formula. So the variance of x should be the expected value of x squared, which we got to be 0.5, minus the expected value of x, which was 0, squared. So we get an answer of 0.5 for the variance. There's more than one way to do that calculation, but that's my favorite way to do it. So when I'm given a probability distribution, I simply find the squares of all the outcomes, and they go with the same probabilities. And then you do these two computations, plug it into this formula, and you're done. There you go. Okay. Problem 6, we're now looking at, they give us the scores for 2 different golfers, and we're going to compute the mean and standard deviation for both golfers and then compare the results. So first thing it says is compute the sample mean and variance. So you have formulas that you've been given to do this, but I'm going to show you how to do it on the calculator because it's a lot faster. So we're going to look at the first golfer. What I'm going to do is hit the stat button, and that's going to bring up this first edit menu, and the first option is edit. And I'm just going to go into there, and this is going to take me to these tables that I can use. And I think I've shown you how to use these before maybe, but if I haven't, if you have anything in the tables, highlight the name of the table, L5, whatever, highlight that name and hit clear. Do not hit delete, hit clear. And you can clear out everything that's in that table. Okay, so in the first column here, I'm going to put the scores for golfer 1. So 39, oops, do that again. 39, 39, 40, 40, 40, 40, 40, 41, 41, 41, 41, 41, 41, 41, 42, 43, 43, 43, and 44. So those are all the scores for the first golfer. Now I'm going to cursor over to the next list and put the scores for the second golfer. 40, 40, 40, 41, 41, 41, 41, 42, 42, 42, 42, 42, 43, 43, 43, 43, 43, 44, 44. And if we've done it right, then we should end in the same, they should have the same number of scores. Okay, so now I've put all of that data into the first 2 columns here. Now what I'm going to do is hit second stat, nope, sorry, not second stat. I'm going to hit stat, the stat button. Then I'm going to cursor over to calculate. And then I'm going to ask it to compute the 1 variable stats. So I hit that, it brings me here. And now it's waiting for me to tell it which list, which column to use. So I hit second 1, and that will put in L1. So this will compute all the statistics for the first golfer, golfer A. So we are computing the statistics for golfer A. So 1 variable statistics, L1, hit enter. It's going to spit out a whole lot of stuff. Okay, so I mainly am interested in 2 things, the mean and the standard deviation. The mean for a sample, remember, is X bar. So right here, it's given me the sample mean. The standard deviation is the S. So here I've got the mean and the standard deviation for the first golfer. So I'm going to write those down over here. X bar for the first golfer is 41.05, 41.0526. And the standard deviation is 1.393. 1.393. Okay. So now I'm going to do the same thing I just did, but now for golfer 2, for the second golfer. So I want to compute the statistics for the second golfer. So again, I hit stat. Then I go over to the calculate menu. I choose the first option, which is one variable statistics. Once it's on the main screen, I then give it L2, the second list, the second column. So I hit the second button, then 2, and that puts in L2 on the screen. Hit enter, and now it's going to give me again the mean and the standard deviation for the second golfer. So here I've got a mean of 41.947. 41.947 and a standard deviation of 1.268. 1.268. So golfer A and golfer B. So we only used the calculator to compute the mean and the standard deviation. Didn't have to do any of the busy work. Okay, so part A is done. Now part B asks, who is the better golfer? Okay, so in order to determine who's the better golfer, we're going to compare the means for the two golfers' scores, bearing in mind that in golf, a lower score means you are a better golfer. So the mean for the first golfer is 41.0526. The mean for the second golfer is 41.947. So first golfer has the lower mean. So the answer here is golfer A. Now part C says, who is the most consistent golfer? Okay, so the most consistent golfer is going to have the smallest standard deviation, because consistency means they don't deviate from their average very much. They golf very consistently. So for the first golfer, we've got a standard deviation of 1.393. Second golfer, 1.268. So this is a lower standard deviation than this. So that means golfer B is more consistent. So we compare the means to see who's the better golfer, and we compare the standard deviation to see who's a more consistent golfer. Okay. So let's look at some more examples. Sorry. Okay. Number 10, we're told that a pair of dice are being rolled 720 times. That's 720. Find the mean and standard deviation for the random variable X, which is the number of times the dice sum to 7. Okay. So the trick here is to realize that even though we're dealing with dice, this random variable X is actually a binomial random variable. How do I know that? Because X is you only count. Okay, so there are only really only two outcomes here. Either the dice sum to 7 or they don't. So we only care about whether they do or don't sum to 7. So since there's only two outcomes, X will be a binomial random variable. So X is binomial random variable. So if we can identify the number of iterations and a number of trials in the experiment, which is the number n, if we can identify the probability of success and a probability of failure, then with those three numbers, we can compute the mean and standard deviation. All right, so the pair of dice are rolled 720 times, so n is 720. The probability of success, what's the likelihood that the dice will sum to 7? Well, that's not really a trivial computation. So, you have one option, and we've done this in the past, is you list out the whole sample space, which consists of all those pairs of dice, pairs of outcomes, and you find the pairs that sum to 7. So when you do that, you will find that you have 6 ways of summing to 7. So 6 out of 36 ways, or 1/6. So the probability of success is 1/6, because there's 6 ways out of the 36 possible combinations. There are 6 ways that will add to 7. Once we know the probability of success, the probability of failure is just 1 minus the probability of success. So that's 5/6. So from here, we can compute the mean, which we know is n times p for a binomial. So that's 720 times 1/6. So we punch that into the calculator, sorry. Oops. 720 times 1/6 is 120. So we have a mean of 120. The standard deviation for a binomial is the square root of n times p times q. So 720 times 1/6 times 5/6. So we punch that into the calculator. Square root 720 times 1/6 times 5/6. Enter, and we get 10. So standard deviation of 10. So the solution to this problem hinged on identifying x, in this case, as a binomial random variable. And once we did that, we just needed to identify n, p, and q. And with n, p, and q, we could compute the mean and the standard deviation directly. Okay. Finally, number 13. Here, we're told, suppose we have a probability distribution with a mean of 35 and a standard deviation of 5. We want to use Chebyshev's inequality to estimate the probability that the outcome lies between these 3 values. So between 25 to 45, 20 to 50, and 29 to 41. Okay. So this isn't too bad. So first things first, looking at the part A here, we're going to say, hey, look, 35 is the mean. 35 minus 25, which is the lower bound of this interval, is 10. And yeah, is 10. And if we do the same thing, we do 45 minus 35, we also get 10. So when you look back at the Chebyshev stuff, you learned that whatever this value is, we call this C, little c. So the probability that we're interested in is does the value lie, what's the probability that the value lies between 25 and 45, which we learned is 1 minus sigma squared over c squared. So that's going to be 1 minus sigma, which is 5 squared, over c, which is 10 squared. So that's 1 minus 5 squared. Let me zoom in. It's a little small. 1 minus 5 squared over 10 squared, which is 25 over 100, which is 1/4. So the answer here is 3/4. And then we do the same thing for the next part. So 20 to 50, I'm going to look at 35 minus 20. That's 15. And if I look at 50 minus 35, these are the means, just to show you that these do end up being the same thing. So 15 above and 15 below. So this is going to be your C. Probability that we are between 20 and 50. Uh-oh. Sorry about that. Spazzing out. Okay, so picking up where we left off, once we know C is 15, then the probability of our variable being between 20 and 50 is equal to 1 minus sigma squared over C squared, which is 1 minus 5 squared over 15 squared. So that's, you punch that into your calculator. 1 minus, and you have to be careful here, 5 squared divided by 15 squared. And we get a probability of about 89.89. If I hit the math button and then hit frac, I can get that as a fraction, so 8/9. Okay, and then we'll do the last one. So here, let's see if I can get zoom in just a wee bit. Now we're doing 29 to 41. So you look again at the difference between these values and your mean. So 35 minus 29 is 6. 41 minus 35 is also 6. So you can see that that will be your C. So the probability that we are between 29 and 41 is 1 minus 5 squared over 6 squared. So 1 minus 5 squared over 6 squared. And we get, calculator, 11 over 36. Okay, so that concludes the problem session for 7.5. This, I hopefully covered most of the sort of things you'll see and gave you some useful tricks on how to use your calculator to make some of these computations easier. Y'all have a good one.